Hi guys, today we're going to learn about graphs of f, f prime and f double prime. Let's look at this problem. So the graph of y equals f prime of x is given above. We have that this is going to be from -3 to 3. You can either put this as a shaded dot, that's fine, or not, okay? So the first question goes like this. For what values of x from -3 to 3 is the graph of f increasing? Justify your answer. First and foremost, you can see that this is the derivative, okay? So this is f prime. What you're seeing is f prime. So if we want f increasing, f is going to be increasing where the derivative is positive. So when this graph is positive, you can see that this is positive when it's above the x-axis. Let's draw it. So if I have this increasing, I have that this part is going to be increasing, and this part, and also this part over here. Why? Because that's above my x-axis. Therefore, we can conclude that f is increasing, okay, on the intervals, and I can see that it's from here to here, so it's -3 to -2, comma, then you have from here to here, which is from 0 to 2, and from 2 to 3. Why this is going on? Because we need to justify our answer. This is happening because f prime of x is greater than 0 there. And that's pretty much it for this problem, okay? So I'm using the function that they are giving me, and I'm concluding based on the question that they are asking, okay? So let's look at part B. So for part B, they want you the x values, okay? And they ask you, does the graph of f has a relative maximum? And then we want to justify your answer. So how do you know that you have a maximum? Before the max min, we need to make sure that we have critical numbers. So let's look at our critical numbers here. What is a critical number? You know that a critical number is when your derivative is equal to 0 or undefined. Therefore, you have a critical number here, here, and here. Okay? More specifically, when we are talking about here, the maximum, to be a maximum, you know that f prime needs to be changing from positive to negative. So this critical number is a relative max. This one is a relative min because it changes from negative to positive. And this one is going to be neither. So the one that we want for this situation, because we want a max, it's going to be this one that you have over here. So we know that f has a relative maximum, okay, at x equals -2, and we know this because f prime changes, okay, from positive to negative there, and that's your justification, okay? That's going to be your justification, the fact that it's changing from here to here, positive to negative, okay? So now let's look at C. For what values of x from -3 to 3 is the graph of f concave down? Okay, so when we talk about concavity, we think about the second derivative. When we think about the second derivative, we think about, if we are seeing the first derivative, we are looking where is decreasing because we want the concave down. So for this matter, the first thing that I would do in this situation, it would be to find my horizontal tangent lines. So you can find that you have here one horizontal tangent line, okay? Here you have another one, okay? And the other one is over here, okay? So you can see that those are going to be important, okay? In addition to that, we want the concave down. Concave down happens when my f prime is going to be decreasing. So this means that this is happening here. This is concave up because it's increasing, and then concave down is going to be this situation over here because that's also f prime is decreasing on this interval, okay? So as you can see, when we talk about concave down, we're talking about two intervals for this situation, okay? So what we can say here is that f is concave down, okay, on the interval -3, -1, okay, and 1 to 2, because f prime is decreasing there. Okay, so to see there's two intervals. You can see from -3 to -1, and then from 1 to 2. Okay, so you can see why it's concave down. Okay, now the last question that we have here to justify our answer is, for what values of x between -3 and 3 does the graph of f has an inflection point? Justify your answer. So to remember the definition of inflection point, you know that to find an inflection point, you have to have the second derivative equalized to 0 or does not exist, and there must be a sign change. Okay, so you know that we need to have an horizontal tangent line or some situation where the derivative does not exist, which that's not happening here. So here we have horizontal tangent lines here, here, and here. In addition to that, you see that x equals -1. You know f prime is changing from decreasing to increasing, and here is changing from increasing to decreasing, and over here changing from decreasing to increasing. So the 3 points are going to be inflection points in this situation. Okay, so you can see that this is an inflection point, this is going to be also an inflection point, and this one as well is an inflection point. Okay, so we can say that f has inflection points, okay, at x equals -1, 1, and 2, because f prime has an horizontal tangent line, and f prime changes from increasing to decreasing, or vice versa, there. Okay, so that's why we have this situation. Okay, so there's two things that we need to have when we have inflection points. Okay, so here, here, and here. Okay, now the last thing that we need to do here is use the information that we have, and the fact that f of -3 is equal to 0, which this is an intercept, to sketch the possible graph of f. Okay, so if I have that this is -3, okay, and that's your 0, so for sure I have the situation, right? After that, what else do you have? Well, you have the intervals, right? We know that f is increasing where it's increasing. Okay, as far as I know, it's from -3 to -2. Then we have that it was 0, 2, and then we had that it was 2, 3. Okay, in addition, we know that f is decreasing on the intervals where -2 to 0. Okay, and then that's pretty much it. Okay, so what else? I have a relative max. We talk about the relative max at x equals -2. We knew that we have a relative min, and we talk about that relative min that happens at x equals 0. What else? The concavity, we know a lot about the concavity, right? So we know that it's concave down. It's the one that we have over there at the top. We have that it's concave down at two intervals. Okay, f is concave down at -3, -1, and 1, 2. And then f is concave up. We mentioned that concave up, it was from -1 to 1, and also from 2 to 3. Okay, so what I would do here to do the sketch, and please remember that this is one of the many options that we have to draw the situation. I would say that doing your max and min, it would be one of the first things that I would do. So since you know that you have a relative max here, and I know that the max should be higher, I'm going to put it there. That's my relative max. Remember, we don't have the y, so that's what we have. And then the min, I know that it's going to be here, so I'm just going to put it low. Okay, so that's your relative min. Okay, In addition to that, after that, honestly, I would go with the concavity, okay? So I know that it's concave down from -3 to -1, excuse me. So you can do something like this, okay? So that's concave down. And then you know that there's a concavity change from -1 to 1, okay? So I would put something like this. That's your 1, okay? This is -1. And you need to touch them in, right? Okay, so you have a situation like this. And after that, you know that the concavity is going to be from 1 to 2 is concave down. So I would just put it like that. And then from 2 to 3 is up. So I would just change it like that. So meaning this is an inflection point. Then the other inflection point that you have is this one, and the other one that you have is here. So everything flies beautiful in this graph. I know that it's not the only option. Please remember that this is not the only option, but this is a really good rough sketch of your graph F. Well, I hope that this was helpful.